All right, everybody. I want to start this presentation with you closing your eyes and imagining. The year is 1700 and huge wooden pirate ships are sailing across the ocean full of shiny golden coins and glittering gems and other beautiful and valuable treasure. Now, most of these pirate ships are going to sail all the way across the sea from continent to continent and islands on the way between, burying their treasure or using it at the coast to buy new goods for their ships or to sell it. But some of these pirate ships are going to be caught by dangerous storms out in the ocean and sunk to the bottom of the sea, where many people will believe that they'll be lost forever. And that may have been true until today, when the engineering ambassadors found a sunken pirate ship at the bottom of the ocean. Now, the only question that remains is how are we going to get down there to explore this wreck and find its treasure? Does anyone have any ideas how we can get to the bottom of the sea? If you said submarines, then you're absolutely right. And you can even see one in the picture here exploring the top deck of this sunken ship. We're going to be using submarines to explore the sea. But first, we have to find out a little bit more about what submarines are, a little bit about the physics behind them, and the engineering that goes into them. I'm Ian Ganavati. I'm a biological systems engineering student at the University of Nebraska-Lincoln, and today I'm going to be your guide. So just as a reminder, this presentation is going to focus on, first, what submarines are, next, the physics that they rely on, and then finally, how we engineered them to allow us to get to the bottom of the ocean safely and happily while exploring a bunch of ruins and wrecks and amazing things that are down there. So let's start off with what submarines are. In general, a lot of us may be familiar that submarines are vehicles that allow us to travel deep under the ocean. But few of us have probably ever been in one or even seen one, especially living here in Nebraska. Submarines are vehicles that are usually used primarily by scientists, engineers, and military personnel to do important work under the sea, whether it's defending the country, conducting important research on animals or rocks or plants that can only be found at the bottom of the ocean, or anything else that you can imagine, experiments or anything like that we really need to be doing deep down in the ocean safely. So in general, with all these different types of people using submarines, they're designed for a variety of different applications. And even though people aren't generally using submarines, there is a tourism aspect to submarines. So many submarines, especially in areas like Hawaii, allow tourists to get in and go down underwater to explore some of the amazing sights that they might see, like coral reefs, the seabed, some amazing wildlife, anything like that. Much more common, submarines are used for other purposes like research. This submarine pictured here is actually featured in the James Bond movie, if it looks familiar. And submarines like this one called the Mantis are used to go deep underwater and collect specimens and other things that scientists want to study. And that's why you can see those little claws on the front that are really important for grabbing things on the ocean bed. Finally, and probably the biggest purpose of submarines, is military applications. The United States alone has about 70 submarines currently in commission, so currently still being used and still active. The U.S. also has the third largest submarine in the world, and they call it the Ohio-class submarine. Now you may be wondering, what's the biggest submarine then? And we'll get to that in just a second. Another fun fact really quick is that Nebraska actually has a Navy, and you can become an admiral in it. And right here in this picture, you see the USS Nebraska, which is not a submarine that's here in Nebraska, but it's cool that we have one named after us. So even though we're here in a double or I think triple landlocked state, we can still be really interested in submarines and be represented by them. So that's a great thing. Now back to the largest submarine. If the US has the third largest submarine, then what country has the largest? Any guesses? Take a second to think about it, and then I'll show you. The country with the largest submarine is Russia. They have the Russian Typhoon-class submarine, which is the largest in the world. And in this picture, you can just barely see on that top part of the submarine a couple of people standing by the side. They look really tiny. There's only one in service right now, and that's partially because it's just so expensive to build and to modernize these submarines. But even though only one is active, they have 6 built. And the number of people that you can fit in here is hundreds, and that's just an estimate, so you don't have any hard data on this, but they can fit a lot of people in the submarines. But instead of just looking at this picture and trying to get an idea, let's try to put in perspective just how big this submarine is. Think about the length of a football field. Pretty long, right? Take you a little while to run across that. A Russian Typhoon class submarine is twice that length. It's 575 feet, or about 2 football fields. I mean, that's massive. But now you might be wondering, how far under the ocean can this huge submarine go? It's so big, full of metal, it's so heavy. Well, the Typhoon can actually go as deep as 1,650 feet below the ocean. That's about 5.5 football fields, 1,650 feet below the ocean. That's pretty deep. And now go back to that question about how heavy is this submarine, right? I mean, this is a 2 football field long hunk of metal and technology. I mean, how much does this thing have to weigh? To be honest, if I told you, it would be hard to even imagine. So I'm going to try to put it in perspective again. Let's talk for a second about blue whales. Who doesn't love a whale, right? They're cute, they're enormous. One blue whale weighs as much as 40 elephants, right? 40 elephants. The blue whale is the largest mammal on Earth, largest animal on Earth, right? And so just one blue whale, 40 elephants. That's huge, just massive. So now I want you to guess how many blue whales the Typhoon class submarine weighs. And just for the numbers out there, one blue whale weighs up to 200 tons. So we'll find out how many tons a Typhoon class submarine weighs. But how many blue whales do you think? Anyone out there think one blue whale weighs as much as as the largest animal on Earth? How about 2 blue whales? Well, the answer may surprise you. It's actually 240 blue whales. Now that is a massive submarine. 240 of the world's largest animals. That's 48,000 tons. All sitting in the ocean, floating, sinking, carrying hundreds of people. I mean, this is an amazing invention. So now let's talk a little bit more about some of the physics behind this submarine. And remember that physics is just some of the principles of how it works, right? Physics is a science concerned with, how the world works, how things work, how does it operate, how does it float, how does it sink? That's what we're going to talk about. So first we're going to talk about the forces on the submarine. Now remember, a force is like a push or a pull. So you pull your hands like this or you push them, that's a force. And so we're looking at a submarine, we need to figure out what forces decide whether the submarine is floating or sinking. And there's really 2 main ones. The first one is gravity. Now that's something that we're all pretty familiar with, right? Gravity is what pulls us to the Earth every day. And when a submarine sits in the ocean, gravity is also pulling it down deeper and deeper all the time. And so how do we counteract that force? How does a submarine sink, or a boat for that matter? Well, the force pushing it up is actually the force of buoyancy. Now, buoyancy is another thing that we may be familiar with. If you've ever been in a pool with like a basketball and you try to shove it under the water and then you let it go and it shoots up, that's buoyancy pushing it up. Buoyancy is the force of the water pushing an object up out of it. All right, and that's another force that we're going to talk about in a little more detail here on this next slide. So buoyancy is important because it allows a submarine to float, but it also is the force that a submarine must overcome to sink and go underwater. And so it's important that we understand it a little bit more. Now we talked about intuitively what buoyancy is. And so it's water pushing an object back up. You can think about a basketball under the ocean, but we need to be specific. We need to know how much force we're going to have to provide to overcome this buoyant force. And when we look at that and try to look at a numerical answer, we can use this equation. Buoyancy equals rho times g times v. And rho is that funny looking p there. So you can think of that p as rho times g times v. In this equation, rho stands for the density of the water. Now that's a constant. Everything has a certain density, and so that's something that we can just plug into this equation. The g stands for gravity. That's also a constant, and is something that we can plug into this equation. Now the thing that we can change, and the last part of it, is volume. So we need to change the volume of our submarine to change how much that buoyant force is operating on it. Now, when submarines are sinking down into the ocean, they have to withstand high amounts of pressure in order not to be crushed by the sea. And now a lot of times it might be hard to think about the fact that water has a lot of pressure, but you can kind of think about it when you fill up a bucket with water, right? That bucket's really heavy. Water has weight and it's being pulled down by gravity just like everything else. And as you go deeper and deeper in the sea, you have more water above you that's coming down, pressing onto you, and that's why you experience more pressure. So if we go 125 feet under the water, we might experience some amount of pressure. Then when we go to 250, we might experience a lot more. When we go to 375, even more. And then finally at 500, we're experiencing a lot. And so it's really important for submarines that go so deep below the water to be able to withstand these high amounts of pressure without being crushed. And that's what we're going to talk about a little bit more. So we talked about, density and buoyancy and gravity and how submarines sink and float. We talked a little bit about how water pressure is important. So how do these submarines actually do these things? How are they created and engineered and designed? Well, first let's talk about the sinking and floating. So submarines use buoyancy to their advantage to either sink or float. The device they use to do this is called a ballast tank, and you can see it on this picture here. It's kind of like a space between two walls that the submarine has. Now let's say you have a submarine that's floating and you want it to sink. Well, to do that, these ballast tanks open at the bottom and allow water, seawater, to come in and fill them. So you can see here on the right that it's about half filled. At this point, our submarine is going to become more dense than the water that surrounds it. So I said density was a constant, and that's true for water, but it's something that we could change for our submarine if we add more stuff to it, right? Density is essentially how much stuff is in something. So adding more water to the submarine is going to make it more dense, and we'll have some more stuff. It's going to become more dense to water. It's going to begin to sink, right? You can also kind of think about it as we're increasing weight, increasing that force of gravity, right? It's like when you fill up that bucket with water, it's getting pulled down by gravity. We're filling up the submarine with water. It's going to get pulled down more by gravity, and that's going to allow it to sink. Now, at a certain point, it's going to be equal with the water, and maybe we're going to want to come back up, right? Come back up to the surface, get some fresh air. At that point, water is actually going to be expelled from the top of the ballast tank, so it can be pushed out. And when we empty it, that's going to allow our submarine to rise again to the surface and do whatever it needs to do. Now, something else that's important to notice here is that these ballast tanks are created by two walls, or two holes is what we call them. And now, one of the purposes of holes is to create those ballast tanks, but another purpose is actually to allow these submarines to withstand large amounts of pressure. The inner hole is especially important for this. It's that inner wall. And it's actually sometimes called the pressure wall or the pressure hole. It's usually made of a really strong, tough material. But having that outer hole also benefits in making sure that the submarines can withstand pressure. So you can remember that that outer hole is important for keeping the water in and also important for some of the structural strength of a submarine, but that inner hole is really what allows the submarine to be tough and withstand all that water pressure that we talked about before. And so if you look at this diagram, and this is kind of just for fun, it shows you where a submarine is going to collapse first if it has too much pressure. And you can see they're really strong around the edges and a little bit weaker in there in the middle. But this is only at really high amounts of pressure. And so it's good to know what the limits are for a submarine and how much pressure is too much. The next thing I want to show you really quick is a video of a submarine surfacing. And you're just catching the end of it there, but pretty dramatic here. It's kind of shooting out of the water. And this video is actually of an emergency surfacing. So usually submarines don't come out of the water that fast, but still pretty cool to see it shooting out like that, catching some air. Now, the last thing I want to talk about is what engineers are actually working on a submarine. So there's no such thing as necessarily a submarine engineer, but we have a lot of different types of engineers who might work together in order to design them, because there's a lot of different parts of an engine of a submarine. So the first one is a structural engineer. So take a second to think about, what could a structural engineer be working on? Well, they may work on the holes that we talked about, right? Those walls that keep the submarine from collapsing. That would be really important. Another type of engineer is going to be a mechanical engineer. Anyone think about what they might work on? Well, they're really going to be working on anything that's a lot of moving parts in the submarine, anything that has to do with mechanics. So the propellers, the engines, they might even help with some of the structure as well. That's something that a mechanical engineer might be really, really focused on when designing this. Next is an electrical engineer. What do we think they might be working on? Well, submarines have a lot of circuits and electrical systems, systems like radar, systems that allow them to know how deep they are, power, all those things are super important. And so that's what an electrical engineer might be involved with. Finally, we have a nuclear engineer. Any ideas on this one? Well, submarines oftentimes need nuclear engineers because they may work on some of the submarine power, or on some submarines that carry weapons for the US military, you may need a nuclear engineer down there who understands what's going on with those. So they're also a really important engineer. And now I've only listed 4 here, but there's a lot of other types of engineers who might be working on submarines. So computer engineers, chemical engineers, even biosystems engineers might be doing something down here to improve the submarine and make sure that it's a safe product or a safe vehicle for all different sorts of people to use. So in conclusion here, engineering really allows us to do some extraordinary things, like exploring the sea hundreds of feet below the surface in a submarine. All the while, we can preserve our happiness, our health, and our safety, and not have to worry about water crushing the vehicle we're in or not being able to rise to the surface. And that's something that's really awesome. Now, does anyone have any questions? I can't really answer your questions in this video, but I'll answer a couple of questions that people usually ask. The first one is, a lot of people wonder, how do people breathe on subs, right? I mean, they go down deep underwater. Where do they get the air from? Well, this is actually where a chemical engineer might come in. Submarines can store air in tanks, or they can create air through a chemical process known as the electrolysis of water. And so you can create oxygen out of water. And that's something that you can maybe Google and learn a little bit more about. Another question that people ask pretty often is, how long can submarines stay submerged? Now this varies, but generally months at a time they can be underwater. And this is especially true for military subs, where sometimes it's really important for them to be down under the ocean for a long time. And so those are some frequently asked questions. If you have any other questions, Google will be your best friend, or you can maybe reach out to the UNL Engineering Ambassadors through an email or something. But hope you guys enjoyed this presentation. There's also an activity on submarines, so check that out. Thanks for listening. Bye.